The remainder theorem states that if you have a polynomial and you divide it by x minus a, then your remainder is going to be f of a. So if you were to plug in, let's say for this first example, 2 into this function here, then our answer would be 41. This will help us, instead of having to substitute a value into a polynomial function, you can just do synthetic division, which actually is a lot easier a lot of the times. So the value f of 3 is going to be the same as if I were to divide by x minus 3. Okay. The factor theorem states that if your remainder is 0, then x minus a is a factor of your polynomial. Okay. Just a reminder, a factor, 2 is a factor of 10, since 10 divided by 2 is 5. With a remainder of 0. So for this first example, instead of substituting 8 in for x and evaluating like we did previously, we're going to use what's called synthetic substitution. And what synthetic substitution is, instead of substituting 8 for x, we're really going to do synthetic division, and the remainder will be the solution for f of 8. So let's set this up. So we're going to put 8 here. Then I'll list my coefficients: 1, negative 10, 1, negative 8, and then 1. Okay, so we'll bring down the 1. And 8 times 1 is 8. Okay, go ahead and add. Now we get negative 16. Add those up. And now we get negative, I'm going to write this tiny here, 120. And then we get negative 128. And negative 128 times 8 is negative 1,024. So we'll add those two up. We get negative 1,023. So that means that f of 8 is equal to my negative 1,023.